In today's episode, we're going to talk about our first manufacturing technique. Now, this is not a very well-known technique, this is not a very used technique, but it is a very interesting technique. This is design education with Mia Tahan. It's called free inner pressure forming. I chose this one because it is really interesting, it's very surprising, and it is a cool way of doing product design. In this kind of manufacturing technique, you don't really talk about the user much. It's not about the product itself, it's more about the technique. So you develop the technique and then you think about applications, which is a different way of doing things. Design is really cool because you can just do your own thing. It doesn't have to be one way or the other. Obviously, if you put the user first, you're gonna have much better selling products and more user-centered products, obviously. And those are the products that people will buy most because they're tailored to somebody's needs or they're answering a problem. This is much more about developing a new technique, developing a new process. It gets its name from the fact that the final shape of the product is going to be random. So free inner pressure forming. Yeah, it's because the shape is going to be random at the end. It's not a precise, every time it's going to look exactly the same kind of thing. Which is, in my opinion, it's really cool because it's industrial manufacturing technique, but it's not all the same. You know, your chair is one of a kind in the sense that it doesn't have the same details as someone else's chair. This forming process was developed by Oskar Zeita, a Polish designer. It started out as experiments that Oskar did in 2005, 2006, and developed into what it is today. He developed this process by looking at inflatable pool toys. I'm sure that you're all familiar with those. It's like the floaties, the way that they make floaties. What's interesting about this is that he took a known process and he made it surprising. Now let's talk about the process, the actual process itself, and how things develop from sheet metal to chair. So his main best-selling and most iconic product that he's developed through this process is the plop chair. Plop chair. I'm guessing plop is referring to how soft and squishy it looks, but then it's not. It's very hard metal. So basically the process starts with sheet metal, obviously. So the process is completely industrialized. There is close to no human interaction when it comes to actually making the thing. It's mostly lasers that do all the steps. So I'm gonna show you this process with my little magnet thingies because they are cool and I like them. So the process starts by cutting on sheets of metal. So it's stainless steel. They take these metal sheets and then they create the shapes on it, and then the laser will come and cut the shapes very precisely. It's a 2D shape. It's a circle and 3 legs, let's say. And they cut exactly the same shape twice, because what's going to happen is that they're going to put them on top of each other, and the next step is putting them on top of each other and then soldering the edges only with lasers again, so very precise work. So it's just soldering the edges, and the idea is that they leave a hole at the bottom where you can't see the hole afterwards, and they pump air into it, and the pressure will cause the metal to separate, the sheets to separate, and to inflate like this, and this will give it the 3D shape that you can see on the plop chair. Actually, the pressure is what gives the product its final shape. You get these pieces that are very hard, but they look like soft material. It's very confusing and it's very cool. Afterwards, you can use any type of finishing that we use today on stainless steel. So you can varnish, polish, you can do any kind of texture, paint that you would normally use on stainless steel. So now we're gonna do some design analysis. Design analysis time. Let's do it. So here we have a version of the plop chair. So it's a stool, standard stool. It's got a seat and it's got 3 legs. Great. So what's particular about these stools is that they are made out of a very strong resistant material, steel, but they look like they're made of balloon. They're made of plastic and it look like an inflatable toy. Here you can see that the way that it holds the stool and holds you is that they've added this little feature here, and you can see it here as well and over here, that I'm guessing at the bottom looks like a little rectangle like that, and so this is what helps the chair stay stable. Pieces are extremely light. They're made of a rugged resistant material, steel. Because there's air and pressure injected, it uses a small amount of sheet metal. So if you were trying to do a stool out of sheet metal, normally you would use much more steel to make the same volumes, I mean. So if you stacked sheet metal on top of each other to make this shape, it would take a lot more steel, and it would be a lot heavier. I don't know how comfortable this chair is. It looks like they've tried to make it a little ergonomic over here, but I don't know how comfortable you would be sitting on this kind of stool. I think that the idea is more showcasing this process and this technique and showing how we can use sheet metal, but it can still look approachable and not cold and, you know, dead, kind of lifeless rather. I think that in your home it's a lot more about a sculptural design feature than it is about comfort and usability, which comes back to what I was saying at first, is this that Oskar Zeita was not trying to create something for users, but rather trying to develop a new process, a new technique. This chair has actually won many awards, including the Red Dot Design Award in 2008, the German Design Council Award in 2008, and the Forum Aid Award in 2009. It only weighs 3 kilograms and can withstand 2 tons worth of loads. And that is very, very impressive in my opinion. Oskar Zeita wants to use this process in a lot of other different fields. So right now it's more furniture design and sculptural installations, but he thinks that using it in architecture would be a good thing, would reduce the amount of material that you need, all the while keeping the sturdiness with the steel. He talks about also using it in spatial design because it is something that is lightweight and that could be useful in space. Your imagination is the limit when it comes to how to apply this process and in what fields you can apply this process. We could even apply it to cars, transportation, you know, make it, because it'll make the cars sturdy, but it'll make them lightweight. So it could be a way of limiting how much petrol we use in cars. Other than that, your imagination is kind of the limit. So let me know what you thought about this process. Did you find it interesting? Would you like me to do more processes like this? Would you like me to do more classical ones? Do some surprising ones like this that are kind of outside of the norms? Let me know in the comments below. Did you think this one was interesting? Did you think it was a bit lame or not really useful? Let me know, let's have a discussion. Please like this video if you enjoyed it. Subscribe for more videos every week. And I will see you later.